Okay, this is section 3.2 on Introduction to Pythagorean Theorem. The questions from 3.2 have to do with the association that the area of the squares attached to the legs of a right triangle will always equal the area of the squares attached to the hypotenuse. So in this particular picture here, this is what we call a leg, and this is a leg. And the legs of a right triangle are the two sides that make up the 90-degree angle. Those are called legs. The longest side of a right triangle is called the hypotenuse. So what Pythagoras said was that if you attach squares to all of the sides of a right triangle, and we call this side A, and this side B, and this side C. If this side right here is A, then its area will be A squared. If this side is B, then its area will be B squared. And if this side length is C, then the area will be C squared. So what he effectively said was that if you square the area of the first leg, or get its area, and you add that to the second leg and you square to get the area, those two areas, area A and area B, added together will always equal area C. So in this one, if the side length is 30, then the area will be 30 squared, which is 900. And an easy way to do that, if you have 30 times 30, the easy way to do that is simply multiply 3 by 3 to get 9 and add 2 zeros. Okay? For 40, 40 times 40, simply do 4 times 4, which is 16, and add 2 zeros. So the area here is 1600. And here, 50 times 50, same idea. 5 times 5 is 25, plus 2 zeros, the area is 2500. Now, if we look at what Pythagoras said, so 900 plus 1600 should equal 2500, and it does. So if I look at 1600 plus 900 and add them together, I get 2500. Question 5 says a right triangle has side lengths of 40, 75, and 85. So here's a right triangle. I'm going to put 40 and 75 and 85, and I'm going to attach squares to all three sides. What are the areas of the squares? So again, same premise as we did before. 40 times 40 makes this area 1600. This area would be 75 times 75, which I'm not smart enough to do. So I take my calc and go 75 times 75, and I get 5625. Now, if I had a special calculator, I could have went 75, and right up here, I have a square button. So if I press that, it still gives me 5625. And the last one would be 85 squared, which is 7225. Okay? So the addition statement that shows the areas of these two squares would be the area of square A plus the area of square B will equal the area of square C, which is 7,225. So this square's area plus this square's area equals this square's area. Question 7 says the sides of a right triangle measure 9, 12, and 15. So again, it's a triangle. It says it's right, so I can put my 90-degree angle there. What is the area of each square attached to the three sides? Well, if this one has a side length of 9, then the area, we get the area of a square by squaring it. So 9 squared would be its area, and that's 81. If this is 12, then the area of this one would be 12 squared, which would be 144. And this one would be 15. Now, I know that that's 9, 12, and 15 because the hypotenuse of a right triangle always has to be its longest side. So given three side measurements of 9, 12, and 15, it doesn't matter where you put your 9 and 12. It could be this one here and this one here. You could reverse them if you wanted. But this one here has to be your longest. And 15 squares we memorized is 225. So write an addition statement. 9 squared plus 12 squared equals 15 squared, or the area of the square attached to the first leg plus the area of the square attached to the second leg equals the area of the square attached to the hypotenuse. 81 plus 144 is 225. Question 9 says calculate the areas for each. So this one would be 4, this one would be 9, and this one would be 16. It then says is this triangle a right triangle? Is it right? Well, it looks right, but if it is a right triangle, it must follow Pythagoras, which means 4 plus 9, this area has to be 13, and it's not, it's 16. So therefore, it can't be a right triangle because it doesn't follow Pythagorean theorem. Question 10 says a triangle has side lengths of 120, 160, and 200. Is this triangle a right triangle? Well, I can actually multiply 120 by 120 the same way I did that first one. I can do 12 times 12 is 144 plus 2 zeros. So the area of this one that would be attached here, I'll do it in red, is 14,400 millimeters squared. If the side length is 120, then its area is 14,400. If the area is, or the side length is 660, I'm going to multiply those together to get its area. 16 times 16 we learned is 256 plus 2 zeros. So the area of this one would be 25,600. And the last one, the easiest one, 200 times 200 is 2 times 2, which is 4, plus 4 zeros. So we have 40,000 as the area of this square. Okay? So it says, is this a right triangle? And again, just like the last one, Mr. Tamtom, it is a right triangle if the area of the two squares attached to the legs of the right triangle equals the area of the square attached to the hypotenuse. And if I add these two together, I do get 40,000, and therefore it is a right triangle. Question 11, the side lengths of a triangle are 5, 6, and 8. Determine whether it is a right triangle. So same thing again. Is this 90 degrees? So we have 5, 6, and 8. Draw our squares on here. This is 25, and this is 36, and this is 64. So 25 plus 36 has to equal 64, and it doesn't. It equals 61. So therefore, this is not a right triangle. If it was, it would have to equal 64. Question 13, a small rectangular flower bed has a square stepping stone at each of its sides. Is the flower bed in the shape of a right triangle? It's a fancy way of saying, is this a 90-degree angle? So 4,800 plus 4,800, if I did it without a calculator, is 9,600. This is 9,800, which means this is, again, not a right angle. If it was, this would be 9,600, but it's not. Question 15 says construction workers have begun to dig a hole for a swimming pool. They want to check that the angle right here, I suppose, well, hang on, how's that even possible? The angle right here, okay, I guess so, is 90 degrees. They measure the diagonal shown to be 9.5 meters. Let's see if that works. So if I draw my right triangle, and I'll draw it just the way it is here. There's my right triangle, 8 and 6. And 9.5. This is 64 and this is 36. That's a 3. So I know based on Pythagoras, if this is a right triangle right here, this one should be 100 square meters. But I know that in order for that to be a 100 square meter area, this length has to be 10, not 9.5. So therefore, I can assume that this is not a 90-degree angle. Correct? Correct. Question 16. Baldeep is building a wooden box for storing colored wooden pencils. The box will have rectangular sides that are 12 centimeters and 20 centimeters long. Show how he can be sure the sides are rectangular without using a protractor. So if I draw my box here, right here, and I put 20 centimeters and 12 centimeters, if this is a right angle, then I should be able to know how long that diagonal will be, right? So I know that this will be 144 as an area. This one here, since this is 20, this is 20, this one should be 400. And if I erase all of this superfluous part of my drawing, I know that this will have to have an area of 544 square centimeters, right? And if it's 544 square centimeters, then the diagonal would have to be the square root of 544, which is approximately, oh, that's not the right number, 544, approximately 23.3 centimeters long. And the last question, is it? Is this the last one? The last question says a right triangle has a square attached to each side. So here's a right triangle. Has squares attached to the sides. Two of the squares have areas of 10 centimeters squared and 15 centimeters squared. That is one possibility. But the other possibility is this. 10 centimeters squared and 15 centimeters squared could be here. So draw and sketch each solution. Those are the drawings you need to have.